So in the last few lessons, we look at what are prime numbers, and we also look at what is index notation. So with this, we are going to now look at prime factorization. So what is prime factorization? So prime factorization involves writing a composite number as a product of its prime factors. So for example, we can express 12 as a product of its prime factors in this manner. So we know that 12 can be broken down into 2 times 2 times 3. And when we write it in index number, because we have 2 multiplied by itself for 2 times, so we rewrite it as 2 squared. Okay, then 3, you only have 8 multiplied by 3 by 1 time, so it's basically times 3. So you might be wondering, how did I get 2 times 2 times 3, and what is this? So let me show you. So we usually use this presentation, okay, and this working to find what are the prime factors of a composite number. So what we'll do is we'll start off by putting this number here. So in this example, we have 12. We'll put it inside here. Okay, and then we find what is a prime factor of 12. So if a number is even, we'll always start off with 2, because 2 will definitely be a factor of an even number. So once I've written here, I'll take 12, divide by 2, and I'll be left with 6. All right. Once I reach 6, next I'll look at another factor of 2. So what prime factor can I, or what prime number can I divide 6 by? So 6 is an even number, so I'll divide it by 2. So 6 divided by 2, I'll be left with 3. I'll write it here. So now I'm left with 3, right? So 3, I will divide it. 3 is a prime number, so I'll divide it by itself, which is 3, and I'll be left with 1. Once you reach 1, okay, you can stop. And these numbers here on the outside tells you all the prime factors of 12. So this tells us that 2 times 2 times 3 will give us 12. So 2 times 2 is 4, 4 times 3 is 12, and yes, this is 12. And we write it in index notation, it will give us 2 squared times 3. All right. All right, so now that I've gone through this example here, I want you to try to write these numbers here, 32, 294, and 108, okay, in terms of their prime factors, okay, and express them in index notation. So I want you to pause the video and try these questions. Once you're done, watch the video and check your answer. All right, so how is it? Let's go through them together. So we'll start off with 32. So we'll use this working here. So 32, so if I were to take 32, okay, it's an even number, so I can divide it by 2. So 32 divided by 2, I'll get 16. Next, 16 is again an even number, so I'll take 16 divided by 2, I'll get 8. 8 is an even number, I'll take 8 divided by 2, I get 4. Okay, then 4 is also an even number, so I'll take 4 divided by 2, and I'll be left with 2. 2 can only be divided by itself, and I'll get 1. 2 can only be divided by itself or 1, so I'll divide it by itself, and I'll be left with 1, so I know I can stop. So based on this, I know 32 is equals to 2 times 2 times 2 times 2 times 2. Since I'm going to multiply 2 by itself 5 times, it is equals to 2 to the power of 5. So that is the answer for question 1. Question 2, we are going to express 294 as a product of its prime factors, and we are going to write it in index notation form. So I'm going to use this working again. So 294 is an even number. So I'll divide it by 2, I get 147. 14 and 7, so I know that is divisible by 7. So I'll use 7, and I'm left with 21. Okay, 21 divided by 7 again, I'll be left with 3. 3 is a prime number, I'll divide it by 3, and I'll be left with 1, and I can stop here. Okay, so I know that 294 is equals to 2 times, the next smaller number is 3, times 7 times 7. So 7 is multiplied by itself for 2 times, so it's equals to 7 squared. So 294 is equals to 2 times 3 times 7 squared. Next, let's express 1080 as a product of its prime factors and in index notation form. So I'll write 1080 here. I'll divide this by 2, I'll get 540. Divided by 2 again, I get 270. Because it's still even, I'll divide it by 2, I get 135. So now I'll divide it by 3, okay? So I get 45. Divide 45 by 3 again, I get 15. Divide 15 by 3, I get 5. Okay, now I've reached 1. So I know that 1080 can be written in the form of 2 cubed because 2 is multiplied by itself for 3 times. Times 3 cubed because 3 is multiplied by itself for 3 times. And times 5. So in index notation, 1080 is equals to 2 cubed times 3 cubed times 5.